This is the EdExcel GCSE 9-1 Maths Paper 3 from the higher tier, and it's from the November 2018 series. Question number 1. For part A, we have to write 7,357 correct to 3 significant figures. Well, if we take a look at the fourth figure, which is 7, because this is 5 or greater, this 5 needs to be moved up to the next digit, which is 6, and so therefore we end up with 7,360 to 3 significant figures. For part B of the question, we have to work out the square root of 17 plus 4 squared divided by 7.3 squared. So if we work this out, we have the square root of 17 plus 4 squared divided by 7.3 squared. And it turns out we get 0.107 798 1356. And so here is our solution. Question number 2. Last year Jo paid £245 for her car insurance. This year she has to pay £883 for her car insurance. We have to work out the percentage increase in the cost of her car insurance. Well, the percentage increase, that's equal to the change in the prices, that is 883 subtract 245, and then we divide this by the original amount 245, and then we multiply by 100. So 883 subtract 245 divided by 245, and then multiplying this by 100, we get 260.408 etc. %. And so therefore we have 260% given to 3 significant figures. Question number 3. For part A, we have to complete this table of values for y equals x squared plus x minus 4. Well, we can use our calculator. If on our calculator we go to the table function, we can key in the function x squared plus x minus 4. We are starting at minus 3. We are finishing at 3. We are going up in ones, and so here is our table of values. When x is minus 3, y is 2. Then when x is minus 2, y is minus 2. When x is minus 1, y is minus 4. When x is 0, y is minus 4. When x is 1, y is minus 2. And when x is 2, y is 2. And when x is 3, y is 8. And then for part B, on this grid, we have to draw the graph of y equals x squared plus x minus 4 for values of x from minus 3 to 3. Well, here is the graph of y equals x squared plus x minus 4 between minus 3 and 3. And then for part C, we have to use the graph to estimate the solution to x squared plus x minus 4 equals 0. Well, where the graph would equal 0 is on the x-axis. And so here we have the line y equals 0. And so what we need to do is find out where the graph crosses the line y equals 0. That's here and here. We have x equals minus 2.5 and x equals 1.5 as our solutions. Question number 4. Fran asks each of 40 students how many books they bought last year. The chart below shows information about the number of books bought by each of the 40 students, and that's what we see here. For part A, we have to work out the percentage of these students who brought 20 or more books. Well, 20 or more books, that would correspond to the category of 20 to 24. And there's 2 students who brought 20 to 24 more books. And so therefore, we have 2 divided by, well, in total we've got 40 students, and then we times this by 100 to convert it into a percentage. 1/20 of 100 is 5, so we have 5%. So we have 5%. And now for part B, we have to show that an estimate for the mean number of books brought is 9.5. You must show all of your working. Well, what we can do to begin with is create a grouped frequency table. So here we've got our table, we've got the number of books, the frequency, then we can find out the midpoints of each of the intervals and then multiply the frequency by the midpoints. From that, we can use the fact that the mean is equal to the total of the frequency times the midpoint of the total of the frequencies. So if I take a look at my table, I've got a category from 0 to 4, and then 5 to 9, 10 to 14, 15 to 19, and 20 to 24. And then we have the frequencies being 11, 8 and 13, 6 and 2, respectively. And so if I find out the total of these, it turns out we get 40. Now the midpoints of each of these intervals, we've got 2, 7, 12, 17, and 22. These are the midpoints of these intervals, and now if I multiply the frequency by the midpoint, we have 22, 56, 156, 102, and 44. And if I add all these together, it turns out we get 380. So the total of the frequencies times the midpoint, that's 380. The total of the frequencies, that's 40. And working this out, we get 9.5. And that's exactly what we wanted to show, that the mean is 9.5. Question number 5. Laura is a skier. She completed a ski race in 1 minute 54 seconds. The race was 475 meters in length. Laura assumes that her average speed is the same for each race. For part A, using this assumption, we have to work out how long Laura should take to complete a 700-meter race. Give your answer in minutes and seconds. Well, what we know is it takes her 1 minute 54 seconds so far to complete a race which is 475 meters in length. Now this 1 minute 54 seconds, what we can do is convert that into just minutes. This 54 seconds we can convert into minutes if we recognize to go from minutes to seconds a times by 60, and from seconds to minutes a divide by 60. Then this 54 seconds, if I divide that by 60, that's 0.9 minutes. So I've got 1 minute plus 0.9 minutes. It turns out that's 1.9 minutes. So this 1.9 minutes would correspond to the 1 minute 54 seconds. And I know that this is equal to 475 meters. And what I want to do is find out how long it will take for 700 meters. And to do that, what I can do is find out how long it will take for 1 meter and then how long it will take for 700 meters. So I first of all need to divide by 475. And if I do that, 1.9 divided by 475, well, that's equal to 0.004 minutes. And then for 700, I have to multiply by 700 on both sides. So if I times by 700, I get 2.8. So I have 2.8 minutes. And what we need to do is write this 2.8 minutes in minutes and seconds. Well, 2.8 minutes, well, that's equal to 2 minutes, and then we've got this extra 0.8 minutes, and if I times that by 60, the 0.8 minutes is the same as 48 seconds. And so what we have then is 2 minutes, 48 seconds. And then, for part B, Laura's average speed actually increases the further she goes. How does this affect your answer to part A? Well, if she's increasing her speed, then we can say it would take less time to cover 700 meters. Question number 6. ABC is a right angle triangle. AC has length 14 centimeters and the angle C is 90 degrees. The ratio of the size of the angle B to the size of the angle C is 3:2. We have to work out the length of AB. We have to give our answer correct to 3 significant figures. Well, the total of angle A and angle B, we've got 180, the sum of the angles in a triangle add up to 180. Take away the 90 degrees, and this 90 degrees would correspond to angle C, and it turns out here we end up with 90. And so what we have to do is divide 90 degrees in the ratio 3 to 2. So I've got the ratio B to A being 3 to 2. In total, we've got 90 degrees. And if I do 90 divided by 5, I get 18. So each part is worth 18. And so for B, we've got 3 times 18, which is equal to 54. And for A, we've got 2 times 18, which is 36. And so if I add these to the diagram, for B, I've got 54 degrees. And for A, I've got 36 degrees. And so what we need to find is the length AB. Now if I label my sides, the AC would correspond to the adjacent and the AB would correspond to the hypotenuse. What connects those is cosine. So we have the cosine of 36 equals 14 divided by AB, and so therefore AB, that's equal to 14 divided by the cosine of 36, which is 17.304, etc. So we have 17.3 given to 3 significant figures. Question number 7. The table gives information about the speeds of 70 cars, and what we have to do is draw a frequency polygon for this information. Now before we do anything else, what we need to do is find out the midpoints of each of these. Midpoint here is 5, midpoint here is 15, midpoint here is 25, and midpoint here is 35. So now we plot the midpoints with the frequencies. So we plot 5, 14 and join that up to 15, 18. So we have 5, 14 joined up to 15, 18, which is over here. And then we join this to 25, 26. So 25, 26 is joined there. And then we join 35 to 12. So that is over here. Here is the completed frequency polygon. Question number 8. The diagram shows a solid metal cuboid. The areas of the 3 faces are marked on the diagram. We've got 27 centimeters squared for the top and bottom, 45 centimeters squared for the front and back, and 15 centimeters squared for the sides. The metal cuboid is melted and made into cubes. Each of the cubes has sides of length 2.5 centimeters. What we have to do is work out the greatest number of these cubes that can be made. Well, what we need to do is find out the total volume of this shape. But for me to find the volume, well, let's suppose we've got x, y and z as our dimensions. Ultimately, we need to find out what x, y and z are. Now to do this, we can form some equations given the areas of the faces. So, first of all, x times by y, so let's write this down, x times by y, that would equal the 27. We also have x times by z, that's equal to 45. And we also have y times by z, which is 15. And from this, we have 3 equations with 3 unknowns, so we can solve these simultaneously to find out what x, y, and z are. Well, what we can do is rearrange for x and z so we have an equation in terms of y only. So from here, we can see that x is equal to 27 over y, and from here we can see that z, that's equal to 15 divided by y. So what we can do is find out what y is by substituting 4 and 5 into 2. So I've got x, which is 27 over y, multiplied by z, which I know is 15 over y, and that's equal, that's 405. And then if I do 405 divided by 45, that's 9. So y squared is 9. So now that I know what y is, I can therefore find out what x and z are. So I have x, which is equal to 27 over y, and I know what y is, that's 3. So it turns out x is equal to 9. And similarly, z, that's equal to 15 over 3, which is 5. So I know what x is, I know what y is, I know what z is. And so therefore, what we can do is find out the volume of the original cuboid, that's equal to x times y times z. So I've got 9 multiplied by y, which is 3, multiplied by z, which is 5. So it turns out that x, y, z, that's equal to 135 centimeters cubed. Now what I can also do is find out the volume of the cube. If I know that each of the cubes has a side length of 2.5, the volume of the cube, that's equal to 2.5 cubed, which is, if I work this out, I get 15.625. And so, therefore, for the number of cubes we can make, we have 135 divided by 15.625, which is 8.64. So I have to round this down and say that the greatest number of cubes I can make is 8. Question number 9. For part A, we have to expand and simplify x minus 2 times 2x plus 3 times x plus 1. Well, what this is the same as is x minus 2 multiplied by, and if I multiply the 2x plus 3 by the x plus 1, 2x times by x, that's 2x squared, and then I've got 2x times 1, and then 3 times by x, so that is 2x plus 3x, which is 5x, and then I've got the 3. So now I need to find out what this is. Well, I've got x times by 2x squared, that's 2x cubed, x times 5x, that's 5x squared, and x times by 3, which is 3x. I've got minus 2 times by 2x squared, so that is minus 4x squared, minus 2 times 5x, that is minus 10x, and I've got minus 2 times by 3, which is minus 6. And if I simplify by collecting like terms, well, I've got 2x cubed, 5x squared minus 4x squared, that is a single 1x squared, 3x times 3x and minus 10x, that gives minus 7x, and then I've got the minus 6 with it. And therefore, what we end up with is 2x cubed plus x squared minus 7x minus 6. And then, for the next part, we have y to the 4 times y to the n divided by y squared equals y to the minus 3. We have to find the value of n. Well, here we need to use the laws of indices. If I have a to the power of m, and I multiply this by a to the power of n, so when I have the same base and I'm timesing, I add the powers. So I have a to the power of m plus n. And similarly, if I have a to the power of m, and then if I divide this by a to the power of n, same base and I'm dividing, I subtract the powers, so I have m minus n. And so y to the 4 times y to the n, that is the same as y to the power of 4 plus n. And then I divide this by y squared, and it turns out I get y to the power of minus 3. Now on the left, I can subtract the powers, so I've got y to the power of 4 plus n minus the 2. That's equal to y to the power of minus 3. So I have y to the power of 2 plus n equals y to the power of minus 3. The bases are the same, and so if we compare the powers, we can see that 2 plus n equals minus 3, which means n is minus 5. So I have n equaling minus 5. For part C, we have to solve the equation 5x squared minus 4x minus 3 equals 0. Give your solutions correct to 3 significant figures. So if I'm solving ax squared plus bx plus c equals 0 using the quadratic formula, the solutions are given by x equals minus b plus minus the square root of b squared minus 4ac divided by 2a. And so what I have over here for my equation is 5x squared minus 4x minus 3 equals 0. Now we can use the quadratic formula. So I have x equals, well, I have minus b, so I've got minus 4 plus minus 4 squared minus 4 times by a times by c divided by 2a. So if I find out what x is, we have minus and then minus 4 plus the square root of minus 4 squared minus 4 a, which is 5, times by c, which is minus 3, divided by 2a. So one of my solutions is 1.27, and my other solution, if I change this plus to a minus, we have minus 0.472. And these solutions are given to 3 significant figures. Question number 10. We are given that f of x is 4 sine of x degrees. We have to find f of 23 given to 3 significant figures. Well, f of 23, that's the same as 4 times by the sine of 23 degrees, which is 1.562, etc. And so to 3 significant figures, we have 1.56. Now for part B, we have to find f of g of 34. Well, first of all, let's find out what g of 34 is. We replace the x with 34. So we have 2 times 34, subtract 3, so we have 68 minus 3, which is 65. And so therefore what we need to do is find out f of g of 34, which is the same as f of 65, which is the same as 4 sine of 65 which is 3.625, etc. And so to 3 significant figures, we have 3.63. And now for part C, h of x is equal to x plus 4 all squared. Ivan needs to solve the following equation. H of x equals 25. He writes x plus 4 all squared equals 25, that's correct. And then he square roots, and he gets x plus 4 equals 5, and then x equals 1. Well, this is not fully correct. We have to explain why. Well, what we should have is x plus 4 equals plus minus 5. When we square root the 25, we get 2 roots, plus 5 and minus 5. And so we have x plus 4 equals plus minus 5. And so there should be two solutions for x. Question number 11, we have to sketch the graph of y equals tan x between 0 and 360. Well, here is the graph of y equals tan x between 0 and 360. We've got asymptotes at 90 and 270. Question number 12, here is a pyramid with a square base ABCD. AB is equal to 5 meters and the vertex T is 12 meters vertically above the midpoint AC. We have to calculate the size of the angle TAC. Now, if we know that AB is 5, that means each side has a length of 5 meters. So I've got 5 meters for AD and 5 meters for CD. And what I can do now is find out the length of AC. And we can do that using Pythagoras. So AC squared, that's equal to 5 squared plus another 5 squared, which is 50. And therefore, the length of AC will equal 5 times the square root of 2. So that's what AC is. So I have AC equaling 5 root 2. And what we will do, because we want to find out what the angle TAC is, well, I know that vertex T is 12 meters vertically above the midpoint of AC. So if I draw a vertical line like so, I know that this is 12. And if I suppose that the midpoint of AC is M, and if I draw the line AM, well, AM, that will equal half of AC. So I've got 1/2 of AC. I'm working this out. We have 5 root 2 over 2. So if I add this to the diagram, I have 5 root 2 over 2 meters. Which is shown here. And the angle I need to find out is this angle here, TAC. Now, there's a right-angled triangle formed. So if I draw out that right-angled triangle again, we have TAM, our right angle here, and then we've got theta over here, and then I've got 5 root 2 over 2 here, and then I've got 12 over here. To find out what theta is, well, I've got the opposite and the adjacent. What connects those is tan. So I've got tan theta equaling the opposite, which is 12, divided by the adjacent 5 root 2 over 2. And so if we find out what theta is, that would equal the inverse tangent of 12 over 2.5, which is 5 over 2, root 2. And it turns out we get 73.58. So I have 73.6 degrees given to 3 significant figures. Question number 13. The number of animals in a population at the start of the year T is PT. The number of animals at the start of year 1 is 400, and given that PT plus 1 is equal to 1.01 PT, we have to work out the number of animals at the start of year 3. So when T equals 1, well, T1, that's the start of year 1. I know that when we have T1, rather P1, that's equal to 400. Now P2, that will equal 1.01 times by P1. So I've got 1.01 times by 400, and if we work out what this is, I get 404. So that's the start of year 2, and the start of year 3, that's P3, that's 1.01 times by P2. So I've got 1.01 multiplied by 404. So it turns out here we get 408.04. So therefore, for the number of bees, we have 408. Question number 14. Y is inversely proportional to the cube of x, and y is 44, x is a, and we have to show that y equals 5.5 when x equals 2a. Well, if y is inversely proportional to x cubed, that means y equals some constant k divided by x cubed. Now I know that when x equals a, y equals 44, so I've got 44 equals k divided by x cubed, so I've got k divided by, we can therefore conclude k is equal to, divided by x cubed. So I have y equals 2a cubed. So I've got y equals 44a cubed. Now 2a all cubed, that's the same as 8a cubed, and the a cubes cancel. 44 divided by 8 is 11 over 2, which is 5.5. And so here y is equal to 5.5. Question number 15, we have to prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. Well, if n is an integer, then odd consecutive numbers are numbers such as 2n minus 3, 2n minus 1, 2n plus 1, 2n plus 3, etc. Now what we need to do is find the difference between the squares of two consecutive odd numbers. Now, for example, the 2n plus 1 and the 2n minus 1 are consecutive. So if I find out the difference between those, I've got 2n plus 1 all squared, subtract 2n minus 1 all squared. So 2n plus 1 all squared, that's 4n squared plus 4n plus 1, subtract 2n minus 1 all squared, so that's 4n squared minus 4n plus 1. So I've got 4n squared plus 4n plus 1, subtract 4n squared plus 4n minus 1, and it turns out here we get 8n. And so, because n is an integer, 8 times by n is an integer, and 8n is therefore a multiple of 8. Question number 16. Here is a solid shape ABCD. The shape is made from a triangle and a sector of a circle, centre O and radius 6 cm. OCD is a straight line. AD is 14 cm. Let's add this to the diagram. I've got AD, which is 14 centimeters. I've got the angle AOD, which is 140. So this angle is 140. And I've got the angle OAD, which is 24. So this angle is 24 degrees. And what we have to do is calculate the perimeter. Now, I also know that the radius is 6 centimeters, which means here I've got 6, and here I've also got 6 centimeters. And recognizing that angles in a triangle sum to 180, the angle CDA, so the angle CDA, that's equal to 180 subtract the 140 subtract the 24, and it turns out here that angle is 26, rather that angle is 16. So the angle here is 16 degrees. Now I know that angles around a point sum to 360, so the angle AOC, that's equal to 360 minus the 140, which is equal to 220. Degrees. And so what we can do is find out the arc length of ABC. So if I do this in a different color, the arc length of ABC, I've got my angle 220, so I've got this 220, and then I'm going to divide this by 360 and then times by 2 times by pi times by the radius, and I know that the radius is 6. So if I work out the arc length will equal, well, I've got 220 divided by 360, and then I times that by 12, so I get 22 pi over 3 centimeters. So this length over here is 22 pi over 3 centimeters. Now I need to find out what CD is. Now to find out what CD is, I can find out what the length OD is using the sine rule. So I've got OD divided by the sine of 24, and this is equal to, well, I've got this 14 divided by the sine of 140, so with this I can find out what OD is. So I have 14 sine 24 divided by sine 140, so if I work that out, I get 8.858, etc. And now that I know what OD is, I can subtract 6 from it to find out what CD is. So CD, that will equal the 8.858, etc., which is what OD is. So this is what OD is. And then I subtract from this the 6, which was the radius. So if I subtract from this the 6, I get 2.858, etc. So I've got here a length of 2.858, etc. And so therefore, for the perimeter of the shape, I've got the length of 22 pi over 3, and I've also got the 14, and I also have the 2.858, etc. And so if we work out the perimeter, I add on to this 14 and then 22 pi over 3, and it turns out we get 39.89, etc. So to 3 significant figures, we have 39.9. Question number 17. The table shows information about the distances 570 students travel to a university open day. So we've got the distance and the frequency, and for part A we have to draw a histogram for this. Now for me to draw the histogram, I need the class width, the frequency density. So if we find out the frequency densities, well, for that I need the class width. I've got a class width of 20 here, I've got a class width of 30 here, 30 here, 70 here, and 50 here. And what I can do to find the frequency density is divide the frequencies by the class width. 120 divided by 20 is 6, 90 divided by 30 is 3, 120 divided by 30 is 4, 140 divided by 70 is 2, and 100 divided by 50 is also 2. We now have enough information to draw the histogram. So the first thing we can do is add on the frequency densities, I have 0, 2, 4, 6, and 8. And first one is 6, and the frequency, the class width is 20, so here I've got 10, then 20. So then I draw a line up to 6, like so, and then join this up here. And then we have the next one, 30, and then 3, so that takes us up to 50, and then drawing a line up to 3. That is the next one. And for the next one, we go from 30 to 80, and that's got frequency density of 4. So this goes up to 4 like so, and then 80 is over here. So then I join these lines up like so. And then for the final two, frequency density is 2. So if I draw that to 200, and then I've got from 80 to 150, so 150 is over here. So here is my completed histogram. And then for part B it says, estimate the median distance. Well, what we can do is find out where the median would lie. Now for this, what we can also do is find out the cumulative frequencies. I start off with 120, add on 90, I get 210, add on 120, I get 330, add on 140, I get 470, and then add on 100, I get 570. And notice how this gives the 570 in total. So now I can find the position of the median. So if I do 570 divided by 2, this is equal to 285. So the 285th position, where would this lie? Well, that's going to be in between the 210 and the 330, so we choose the higher one up. And so therefore, we can conclude that the median is in the 50 to 80 category. And so what we can do now is actually find out where the median would lie. And we can do this using linear interpolation. So if I draw a diagram, such as the one here, we know the median is in between the 50 and the 80. Now if I go back to my table, I know that there are 210 less than or equal to the 50. That's how many students I've got who travel that distance. And I know for the 80, well, I can see that there are 330 less than or equal to 330. Rather, less than or equal to 80. And the median is the 285th value. And what I need to do is find out the corresponding value of m. And we can do this by recognizing that the gradient of a straight line will be the same for whatever point I've got on the line. So if I think about how I find the gradient of a line, I've got m subtract 50 divided by 285 take 210. That's equal to 80 subtract 50 divided by 330 subtract 210. And so m is equal to this value here multiplied by 285 take 210 plus the 50, so I can find out the median. I have 80 take 50 over 330 take 210, and then I've got 285 take 210 plus the extra 50, so it turns out we get 68.75, and so therefore the median is 68.75 meters. Question number 18. A high-speed train travels a distance of 487 kilometers in 3 hours. The distance is measured correct to the nearest kilometer. The time is measured correct to the nearest minute. By considering bounds, you have to work out the average speed in kilometers per minute of the train. To a suitable degree of accuracy, you must show all your working and give a reason for your answer. Well, the time is measured in the nearest minute. Here we've got hours, so we can convert the hours into minutes by multiplying by 60. 3 times by 60 is 180. So 3 hours is 180 minutes. What we can now do is find out the upper bound and the lower bound of the distance and the upper bound and the lower bound of the time. And from that we can find the upper bound and the lower bound of the speed. So the upper bound of the distance, if it's rounded to the nearest kilometer, then the upper bound will be 487.5 kilometers, and the lower bound of the distance will be 486.5 kilometers. The upper bound of the time, that's, well, if it's to the nearest minute, the upper bound is 180.5 minutes, and the lower bound of the time, that's 179.5 minutes. And so what we can do is find out the upper bound and lower bound of the speeds. The upper bound of the speed, now when we talk about the upper bound of the speed, what we are talking about is we want the value of the speed to be as big as possible, and for that we need the upper bound of the distance divided by the lower bound of the time. So let's work this out. I have 487.5 kilometers divided by 179.5 minutes, and if I work out what this is, it turns out we get a value of 2.715877437 kilometers. per minute. Similarly, for the lower bound of the speed, I have the lower bound of the distance divided by the upper bound of the time. So the lower bound of the distance, that's 486.5 kilometers, and the upper bound of the time, that's 180.5 minutes. So now if we work out what this is, we have 486.5 divided by 180.5. So here I get 2.695290859 kilometers per minute. And hopefully then what we can conclude is s, the speed, that's equal to 2.7 kilometers per minute. And the reason it's 2.7 kilometers per minute is because both the upper bound and the lower bound of the speeds both round to 2.7 to one decimal place. Question number 19. We have to solve algebraically the simultaneous equations 2x squared minus y squared equals 17 and x plus 2y equals 1. Well, what we have so far is 2 times by x squared subtract y squared equals 17. We'll call this equation 1. And we also have x plus 2y equals 1. We'll call this equation 2. And from equation 2, we can rearrange to say that x is equal to 1 minus 2y. We'll call this equation 3. And now we can substitute in equation 3 into equation 1. And this will allow us to find out what y is. So I have 2 multiplied by x, which I know is 1 minus 2y, and then this is squared, minus y squared equals 17. And if I expand this, I've got 2 times by 1 minus 4y plus 4y squared minus y squared equals 17. 2 minus 8y plus 8y squared minus y squared is 17. And if I rearrange, 7y squared minus 8y minus 15 equals 0. Now what I need to do now is solve this equation, and I can factorize it. I need 2 numbers which multiply to give the 7 times by minus 15, which is minus 105, but which add to give minus 8. And what you'd find is those 2 numbers are minus 15 and 7. So we have 7y squared plus 7y minus 15y minus 15 equals 0. So factorizing by grouping, if I split this down the middle, we have 7y times y plus 1 minus 15 times by y plus 1 equals 0. So I've got 7y minus 15 times y plus 1 equals 0, and if 7y minus 15 is 0, that would mean y is 15 over 7, and I also have y equals minus 1. And from this I can substitute these back into the x to find out what y is. So when y is 15 over 7, the corresponding x value is 1 minus 2 times by 15 over 7, which is equal to minus 23 over 7. And when y equals minus 1, x is 1 minus 2 times minus 1, which is 3. So, for my solutions, I have x equals 3, y equals minus 1, and also I have x equals minus 23 over 7, and y equals 15 over 7. Question number 20. I've got triangle A, which is transformed by the combined transformation of a rotation of 180 degrees about the point minus 2, 0, followed by a translation with vector minus 3, 2. One point on triangle A is invariant under the combined transformation, and what we have to do is find the coordinates of this point. Well, what we'll do is we'll rotate the shape 180 degrees about the point minus 2, 0. Well, minus 2, 0, that's over here. And so if I rotate shape A about this point, what we end up with is shape B, which is this over here. So this is shape A1 there. And then what's happening is shape A1 is translated with vector minus 3, 2. So if I take this point, say, I go 1, 2, 3 to the left, and then 2 up. So for my shape, I would have this shape over here, and we'll call this shape A2. Now it says one point on triangle A is invariant under the transformation. Well, if I think about it, what's happening is, if we grab a different colour, this point over here, when I rotated it, that would correspond to this point over here. Rather, corresponds to this point over here. And this point over here corresponded to this point over here. So the point that's invariant, the point which does not move, would be this point over here. That was the one that stayed sort of in the middle. So the coordinates of that point would be minus 3.5, 1.